Hey guys, so we're doing exercise 14C now in question 1, and we're just going to go through and see where it takes us. Turns out it takes us to very interesting places, so let's get started. So part 1 says, what's this? The probability of a target shooter hitting the bullseye with any one shot is 0.2. This means P is equal to 0.2. Shooter takes 5 shots, so now we know that N is equal to 5. So we've got to find the probability of missing the bullseye every single time. Well, we need to define what our success is. So let X be the number of hits of the bullseye. I spelled that right. I hope I did. And so we can say that X is distributed as a binomial. The parameters are 5 and 0.2. Now, in the first one, it's like a double negative. We miss the bullseye every time. That's bad. That means in the first one, in part 1, that means we have 0 successes. So we want to find the probability that X is equal to 0. Now, there are, of course, 2 ways of doing this. We can do this by hand. And so how about we set this up by hand? And we do this as 5C0, 5 shots, 0 successes, multiplied by our 0.2 raised to 0 and 0.8 raised to the 5. Well, a couple of things. We should know by now that 5C0 is equal to 1. 0.2 to the 0, well, we already knew that was equal to 1. And so we just need to work out what 0.8 to the 5 is equal to. So we can do this on our calculators, and how about we try and do that now? Just bring up my calculator, if I can find it. There it is. And so I'm going to do oh gosh, what am I doing there? Okay, I'm going to do 0.8 to the 5. Better still, how about I make that in brackets? 4 over 5, close brackets. And we're going to raise this to the power of 5. So raise to the power of 5 equals, and here I get an answer which is exact. So I'm just going to jot that down, equals 1024. I think that was over 3125. Let's just double check because it disappeared as soon as I started writing. Ah, yes, it was indeed that. Now, the other way of doing this is to actually use your calculator and use Binomial Pdf. So let's do it using Binomial Pdf. So if we're doing that, we're going to go Binomial Pdf, and we're going to say that we wanted 0 successes. There were 5 trials. The probability of success was 1 out of 5. Let's see if that works as well. And we know that it should. So we go up to here, interactive, distribution, discrete, Binomial Pdf. 0 successes, number of trials is 5, probability of success was 0.2, press OK, and there we have it. But is that the same as the answer we got before? Well, that's the problem with Binomial Pdf. It actually doesn't give us an exact answer. So what we're going to do with this one is we're going to convert it into a decimal, and lo and behold, it does give us the correct answer. So we're pretty happy with what's gone on so far. Now, in the meantime, let's get back to the question, because in part 2 it said, what's the probability of hitting the bullseye at least once? So in part 2, we want to find probability X is greater than or equal to 1. Now, what we're meant to do with this is to realize that probability X greater than or equal to 1 is the same as 1 minus probability X equals 0. Good news! We've already worked out the probability that X is equal to 0. So our answer is just going to be 1 minus 1024 over 3125. And goodness gracious me, we've got to do that, don't we? I'm feeling extremely lazy. No, I'm not. I'm feeling pretty good now. So I'm going to make this into 2101, I hope, over 3125. Oh gosh, I'm having an existential crisis. So how about we just try that on the calculator? Let's go to this one here, bring it down here. I'm going to make that 1 minus that one. Whew. Oh, the relief. And there's our answer. Now remember, on our calculator, we've also got the possibility of using Binomial Pdf. So if we wanted to do that question from scratch, let's just click in here. We can go to Distribution, Discrete, Binomial Pdf, and the lower value, go right back to start, was 1. The upper value was 5. The number of trials was 5. The probability of success was 0.2 equals 0.67. And the rest of it, is that the same as the answer we got? Let's just take it down here and let's do a little quick check. And yes, it is. So we get the same answer doing it both ways. So far, we're pretty happy with the way things are going. So now I've skipped up to part B of question 1. And it says, what's the smallest number of shots the shooter should make to ensure a probability of more than 0.95 of hitting the bullseye at least once? Well, there's a lot of work involved in this question, so let's make a start on it. So we wanted to hit the bullseye at least once, so we want to find probability x is greater than or equal to 1. We want the probability to be more than 0.5, so we want this to be more than 0.95. This is an interesting question because it says, what's the smallest number? In other words, we don't know what n is equal to. N is the unknown. So we've got to try and find a way of working out what the n is equal to. I'm going to go through a few ways of doing exactly that. So going back to our question here, remember that could be written as 1 minus probability x equals 0 is greater than 0.95. And we could just take the 1 across the other side, make that minus PR x equals 0 is greater than negative 0.05. We divide both sides by the negative, so probability x equals 0. Oh wait, that's less than, isn't it? 0.05. So now, if we're doing this by hand, here's what we could do. We could now write this as probability x equals 0, NC0, where we don't know what the n is equal to. Our probability of success, remember, was 0.2. That was raised to the n. No, I beg your pardon, that was raised to 0 because there's no successes. 0.8, that was the one that was raised to the power n, and that has to be less than 0.05. In the meantime, NC0 is equal to 1. 0.2 to the 0 is equal to 1 times 0.8 to the n is less than 0.05. So what we've got to do is we've got to find or solve for n. Let's do that on the calculator. So bring the calculator up again. And here it is. Got the same calculation there from previously. So this time we're going to solve. And we've got 0.8 raised to the, I'm just going to use x here. And we're going to say where that is less than. Now we get the less than from math 3. So it's less than 0.05. And we're going to solve that for x. We're going to close that bracket. We're going to cross our finger. And, yuck, what's going on here? Don't like that. How about we make that into a decimal? And now we've got ourselves an answer. So what it's saying here is that n is greater than 13.4. N is greater than 13.4. Now it must be a whole number. Therefore we say n is equal to 14. And that is our answer. But what if there was another way of doing it? Well, there is another way, and we're going to look at that in just a minute. Okay, so the other way of doing it is to actually go to our graph. So what we're going to do is we're going to recall that probability x equals 0 on our graphs. We could use Binomial Pdf. Now remember, we didn't know what n was equal to. We did know that there was meant to be 0 successes, so we put in 0. The number of successes we didn't know, so we're going to put that in as an x or n. Maybe I should just write that as n, but on the calculator I'm going to put x. And the probability of success was, that was 0.2, wasn't it? We're actually going to put this into our calculator into y1. Okay, just move that across a little bit. Leave us room to bring the calculator up, and let's see what actually happens. Okay, to get the binomial, the way to get that is you need to bring your keyboard up. So let's bring the keyboard up. We actually need to go diving deep into here. We've got binomial down here somewhere. And there it is, Binomial PDF. And we're going to input that. Oh, no, I did the wrong one, didn't I? So how about we clear that? Binomial PDF, that's the one I want. Okay, I'm feeling a lot more confident now. So what I wanted to put in here was exactly what I wrote before. So 0, x, 0.2. I'm going to close brackets. I'm going to just enter that. And I'm fairly happy with that. But now what I do is I go to my table of values. Remember the table of values is this little thing up here. So we're going to click on the table of values. And what we're doing is we're looking here down the side, X values. Remember, they're our N values. These are a number of trials. So the way we'd read this is, if N was equal to 1, our probability X equals 0 is 0.8, and so on. We're actually going to scroll down here and look for the first time when it becomes smaller than 0.05. Now, here's a little problem. We've got to 8, but we've stopped there. Now, the reason we've stopped is because up here, at some point, we told the calculator we didn't want to go any further than 8. So how about we go crazy? How about we make that 20? Here we go, right on a limb here. And so now, when we look at our table of values, we're going further than 8. And we're looking for the first time that it goes below 0.05. Oh, it's pretty close there, isn't it? Oh, it's so close there. Oh, not quite. A little bit more. And there we see it. When we get to 14, that's the first time we've gone below 0.05. So we get the same answer that we got before. So that's a way of doing it using Binomial PDF and using the table of values on your calculator. Very useful way of doing it. And in fact, that's going to be a bit of a clue as to how we do the second part or the next part coming up.